I'm just going to start you basic with matrices, adding and subtracting them and multiplying by a scalar. Your scalar is just a number, nothing to be scared of. It's actually pretty simple. Now I like to think ahead. I am the non-procrastinator. I'm sorry, I am the complete opposite of a procrastinator. I try to do everything way ahead. So in fact, I've actually planned out the entire chapter, and I'm going to tell you right now, your chapter test will be on December 13th. For those of you that like to think that far ahead, December 13th will be your matrix chapter test. And that is also when the chapter 4 chapter test from the book will be due. Like that? Look, I'm already that far ahead. You already know to start it. Now, matrices are one of those things that you use in your everyday life. You just don't realize it. You probably use it quite often, maybe once or twice a week, but you just don't think of it. Raise your hand if you like to look at baseball statistics. Anybody in this room like to look at, oh, I've got several. Okay. Baseball stats are all set up as a matrix. You've got your players down here. You've got their stats going up here, and then you have their individual stats, right? Their RBI, their errors, their home runs, and things like that. So that's if you're looking at sports statistics. That is a giant matrix. Raise your hand if you've never looked at sports statistics. That's okay. So you guys have also looked at matrices. You just may not realize it. Raise your hand if you have ever looked at a recipe and made something from a recipe. You all had no mess, didn't we? Mm-hmm. Yeah. That's a matrix. Where you have your ingredients here and you have how much you need. That is a matrix. Raise your hand if you like to look at the weather in the morning to figure out what to wear. You like those 5-day forecasts? Yeah? 10-day forecast, 5-day forecast? That's a matrix. You have the days of the week, you have the temperatures. That's a matrix. A matrix is just a way of holding certain information. Now, I guarantee all of you, oh, maybe not. This is throwing me off here. I bet you half of you have used a matrix in Word. Anybody have Mrs. Steele? You did? Okay. This may work for you guys for sure. You have Mrs. Boyer for typing. I'm not sure if it's 7th grade typing or if it doesn't happen for 9th grade. You insert a table into Word. Raise your hand if you've ever inserted a table in Word. That's a matrix. That's just a matrix. Okay. So here's our first problem. And we're looking at the dimensions of this matrix. So go ahead and take a minute, copy it down. Copy the word dimensions also. Dimensions are a way of telling me how big this matrix is. And it doesn't work just to count how many elements are in it. There's 6 elements in it. But I don't know if that's going to be a 6 by 1, a 1 by 6, a 3 by 2, a 2 by 3. All of those multiply together. Sure. Not quite. It's a 3 by 2. But here's why. We actually tell a dimension by rows, by columns. It's how many rows it has by how many columns. Now, one thing I recommend to help you figure out how many rows so you don't make the Jake mistake, okay, because it's a common mistake. I actually draw horizontal lines in. How many lines do I draw?
3.
So it's 3, and then I draw my vertical lines by 2. So the answer is just a 3 by 2. I honestly draw the lines in. Now, probably not as dark as that blue. Like if I'm using pencil, I draw it very lightly. Or I just pretend to. But that helps me to figure that out. So I'm going to switch the slide. This time you do not need to write the matrix. Just write the dimensions down. Once again, you do not need to write the matrix. Just write the dimensions down. Once again, make sure you're thinking of the Jake idea here where you want to go horizontally first. So the answer should be 2 by 4. Anybody want to admit that they messed it up? They switched it? It happens, right? It's a common mistake. So draw those lines in, whether you draw them into your head, whether you draw them actually with pencil, but draw them in, okay? It will help. So here's our next problem. Go ahead and copy it down. And then think about the answer. All right. On the count of three, I want everybody to yell what the answer is. 1, 2, 3.
Yes.
Yes, they are. They are equal, meaning they are the same. First off, you have to check dimensions. They're both 2 by 2. By the way, a 2 by 2, 3 by 3, 4 by 4s are called square matrices. They're my favorite, especially if you ever accidentally switch the rows in your columns. It wouldn't matter on them. They're my favorite. Okay, but you do look that in the same lower right-hand corner, the 3. Upper right-hand corner, they're both -1. And if you change -1/5 into a decimal, you get -0.2. And 5/2 is a decimal, is 2.5. So they have the same numbers in them, then they are identical. So let's learn to add. Now, adding is not too difficult. But before we can add them, once again, before we can add them, I'd like you to write the dimensions of each of those right underneath them. So write those dimensions down for me. So it's Sabrina. Sabrina, what are the dimensions of the first one? Lovely, pick a friend. How about the second one? Notice they're exactly the same. If they're exactly the same, you are allowed to add them. What do you think would happen if they're not exactly the same? We can't add them, is correct. You'd actually write not possible. Okay? And so what you're going to do is you're going to make another matrix that again is a 3 by 1. So I'm keeping the dimensions exactly the same. And I add 0 plus 1 is 4 plus -9, and 3 plus 8. And I'm done. That's all there is. Let's have you try one more by yourself. Copy it down, write your dimensions, solve it. Haley, pick a friend. Angela, what are the dimensions of the first one? Pick a friend. How's the second one? Oh, they weren't sure which Sammy there. Sammy, who are you picking? Mackenzie. What's the answer?
5, 3, 0.
Again, it's 2 by 2. Any questions? All right, last one of adding. Copy it down, write your dimensions, write your answer. Mackenzie, pick friend. Kinsey, what are the dimensions of the first one? Perfect, pick a friend. Katie, how about the second one? Lovely, pick a friend. What's the answer? Good. Not possible, and why? Do you remember why? That's right. They're not the same dimensions. They cannot be added. Let's multiply by a scalar. Now, I'm going to guess several of you have already done this. Whether you did it in class. Raise your hand if you've done this in class already. Okay. Or whether you've done this at home and you just didn't realize. Raise your hand if you've ever doubled a recipe. Oh, good. You've done this. When you double a recipe, what do? Multiply what? Multiply just the flour? Everything, right? Every single thing. So what do you think I'm going to do with the 6? Good, go ahead and do it. Multiply everything. hurry, close the gate. 6 times 8 is 48. Oh, little kids used to do that one. It was cute, so I say it all the time now when I do 6 and 8. I don't know why. Just little random things you learn. All right, here's our next problem. This is just a minus sign in the middle. I just put a box around it for some reason. So take a minute, copy that down. So here's our next problem. And you know what we haven't talked about for a long time? Who? I can't. You're not favorite, that's right. Yeah, we haven't talked about my Aunt Sally for a long time. You remember her? Remember your dear Aunt Sally? What'd she tell you to do first here? She says parentheses, but there's no parentheses. She says exponents, there's no exponents, so I multiply. What am I going to multiply here, Noah? Inside where? Only the first one. Notice the negative one's only touching the first one, right? It doesn't say go to the second one. So then multiply that first matrix by negative 1. I'm going to rewrite it. Now, some of you may be able to do this without showing the work. But let's say you make a small mistake. Do you think you'll get any partial credit if you don't have work? No. So make sure you show some in-between steps if necessary. Those past couple problems we've done, there's no in-between steps. Okay? Oh, I see subtraction next. I hate subtraction. I do. I hate it. Remember, we've talked about that a few times. You change all these sides? That would work. Now, I'm not telling you you have to, but you make a lot less mistakes if you do what I tell you to. Again, I'm not telling you you have to, but I've seen people that subtract a negative or subtract a positive and they mess up. But they're very good at adding. Now go ahead and add them together. There's my answer. Any questions? That's perfectly fine, Miss Nicholson. But, Sydney, I'm going to be very honest. I see a lot of kids that try to do 9 minus negative 4 and they give me the number 5. If you're really good at subtracting, go with that. But think about which one are you better at personally. I'm better at adding. Raise your hand if you're with me. Switch it to adding. It's going to be easier if you just raise your hand. Okay? It doesn't take much more either, does it? All right, last problem. Are you ready? Oh boy. Copy that. So we're going to solve for x and y on this problem. We already talked about the differences between this problem and the last problem. But before we can actually solve for x and y, we have to pick which one we like better. Alex, what letter do you like better, x or y? Okay. I didn't care what he said then. It really doesn't matter to me. Alex chose y. We're going to start with y. So what I'm going to do is I'm going to highlight the letter y. The rest of you go ahead and circle that spot. And we're going to circle the spots that match up with that. Notice it's in the bottom right-hand corner, right? Correct. I should use the word correct instead of right. So I'm going to circle the same one over here, which is what number? I'm going to circle the same one over here, which is... And notice, though, there's a scalar. Do you see the scalar? The number? The 4. That 4 is necessary. Now we're going to write an equation with everything I've highlighted. So I have a 4. What do you see next? Parentheses. 2y. Then plus 6 equals 8. Everybody I got that equation? Solve it. Solve that. Told you, toughest one of the day, right? Really, it is the toughest one of the day. You've been adding and subtracting. Now you actually have to do it both together, adding, subtracting, multiplying. Now this is intriguing to me. Raise your hand if you distributed. I'm not going to just because I'm lazy. Mainly because I see that if I divide this by 4, what number do you get? 2. And I can solve that. So I get negative 4, and I get y equals negative 2. Raise your hand if you distributed and got negative 2. Hey, it works either way. Now, am I telling you you need to do it my way? No. Go with the way that went in your head first. Okay, go ahead and do the same thing with the x's. Circle the things you need, or underline, or whatever you want to do. If you don't want to use circles again, you could squiggle around it. If you're that crazy kid that carries around highlighters, you can highlight them. Alright, I was the kid that carried around the highlighters and the magic markers and the colored pencils. I was prepared. Teacher said we were coloring something, I had my stuff to color. I was ready. Did you get 6? No.
Yeah.
Did you distribute colors? Did you start with this equation? You see? Okay. I want to fix you if you didn't get it right. Now, remember every problem we've done except for this problem? Every one of those can be done in a calculator. It'd be more effort, I think, than actually doing it in your head. Okay? But this problem here is one of the problems you actually have to be able to do by hand. You cannot use a calculator for. I don't know how to use a calculator for this one. That's why I'm telling you that. Okay? If I knew how, you knew I would teach you that. Actually tomorrow, why not? I'll show you how to put these in a calculator too. If they don't have letters. If they have letters, I'm sorry, can't do it. Make sense? Alright, do it this time. Pull out a clean sheet of notebook paper for your essential work.